let's take a minute and review why we gather data and cover a couple of concepts about how we sample and about what the relationships between variables tell us. So data is giving us information. It's giving us information about the world. We use the data to understand the world, to make predictions. We often can't gather data from every individual that we're interested in, that there's a large population out there that we're interested in, and we're going to talk to a subset of it, of that population, or we're going to gather data from a small group. It is possible to draw a sample that looks just exactly like the population. Sometimes we are able to do that, and sometimes we're simply not able to do that. Let's talk about a time where we are able to do that. I'm going to represent the idea of population here with a cloud, because we can't really see the edges of it. We don't know all the members. We often don't know all the members in a population. And then I'm showing that we're drawing individuals or situations out in a sample here. If we can identify all the members of the population, then it's possible to draw what we call a simple random sample. In a simple random sample, every member of the population has an equal chance of being selected, and therefore it looks exactly like the population. It is representative. So there are two simple steps. Simple. You have to identify all members of the population, and then you have to select the sample so that each member has an equal chance of being selected. If you can do that successfully, then your sample will look just exactly like your population. If we've done that, then we could make predictions about other members of the population based on what we know about the sample. And it's those predictions that is the information that the data is giving us. The data set that we're using in this tutorial is a known population. There were 2,128,948 soldiers in the United States Army during the Civil War, 1861 to 1865. We know them. There was a record of them. Their names were written down. So in this case, the population is very well defined and very well known. So for example, we can take that population and then start splitting it into meaningful subgroups. So for example, we could split that by rank. We can say we know that approximately 91% of that population were in the lowest rank, the rank of private, and approximately 9% were all the other higher ranks. Now, our simple random sample should show pretty much the same pattern, that 91% of the sample are private and about 9% are higher rank. We can also divide the population into other meaningful subgroups. So for example, we know what members of the population were assigned to the infantry, and it was about 70%. And we know what members of the population were assigned to non-infantry duties, and that was about the remaining 30%. And so again, a sample drawn should look just about like the population. There'll be some sampling error, but it should approximate that underlying population. So what does this mean? How does this give us information? So we could make predictions. If I know the proportion of privates to higher ranked soldiers, then I can predict if I draw one more individual out of that pool of that population, there's a 91% chance that he's going to be a private. If I draw one soldier out of that population, there's a 70% chance that he's in the infantry. One thing that we don't know just by looking at those single variables by themselves is whether the variables are related to each other or whether they're independent of each other. And the data can tell us that. So we can ask the question, if we split the population by those two variables, are the patterns the same? If they are the same, then there's no relationship. If the patterns aren't the same, then we can say that the variables are related to each other. Let's have a look at what I'm meaning by that. So I'm going to split the sample along the levels of one of the variables, and then split each of those groups along the levels of the other variable. And we're going to ask, do we see the same pattern or different patterns? So in this case, I'm showing the sample as a circle because the sample is a defined group. We know where the edges are. We have chosen a sample of 4,295 records from that population. 91% of them are privates and 9% of them are higher ranked. And so there's the dividing that among that one variable. And so if I split those into two separate groups and say, let's look at within the privates, how are they divided by infantry and non-infantry duty? What percentage is that? Is it roughly 30% of that 91%? In the non-infantry, is it roughly 70% of that 91% in the infantry? And then we ask the same question for those in the higher rank. How is that proportioned? If we see the same pattern, if duty is distributed roughly 70-30 in both of those groups, the privates and the higher ranked soldiers, then we'd conclude that the two variables are not related to each other. The pattern of one variable is independent of the pattern of the other variable. Knowing where you are in one variable doesn't give me any more information about where you are in another variable. But if we see a different pattern, so what if within the higher ranks, the duty assignment was 50-50 between infantry and non-infantry? Well, within the privates, the duty assignment was 80-20, infantry to non-infantry. Then we'd be able to make even more precise predictions about other members of the population. Here's another example for you. If I told you that there were 4 members of my household and half the members of the household were female and half the members of the household were male, and then I told you that half the members of the household have pink as their favorite color, you could ask, well, is that independent of gender or is that related to gender? If we found that it was related to gender, that only the females liked pink and none of the men liked pink, then as soon as you know one level of one variable, this person is male, then you would know their response on another variable. Therefore, they won't like pink. And that's the power of data. That's the power of seeing these patterns and gaining this information.